There has been a lot of confusion in the news about the modes of transmission of the coronavirus. In this lecture, I will explain how SARS-CoV-2 spreads through the air, and you will see not just in droplet form as we've been told, but also in finer mist and particles which are invisible to the eye. First, when the pandemic really started in most of Europe and the United States, and it was already starting to spread fast in Asia as well. In March 2020, the WHO told us that the COVID-19 virus is transmitted between people through close contact and droplets, not by airborne transmission. However, 10 days later, still in March 2020, the WHO released another announcement saying that in the context of COVID-19, airborne transmission may be possible in specific circumstances and settings. Moreover, the Chinese Center for Disease Control and Prevention confirmed just a little later than that aerosols are possible transmission pathway for SARS-CoV-2. Okay, so aerosols, we're going to talk about aerosols here. And what is the difference between large droplets and aerosols? In a news article published in the journal Nature, experts who work with airborne respiratory illnesses and aerosols told us that there is no doubt that airborne transmission of the virus is to be expected. Several other scientific articles published in the last several months clearly show that the virus spreads in the air, not just in large droplets, but also in smaller droplets and in very small particles, all invisible to the eye. All right, and these can be carried away over long distances. So that's what we're going to talk about here in detail. All right, so these are some of the early published data on this. And in another paper in Nature, again, published a little bit earlier in 2020, other scientists proposed that the disease could be transmitted by airborne transmission. Virologist Kay Lan from Wuhan University collected and studied samples of aerosols from spaces around people infected with COVID-19. He wrote that SARS-CoV-2 aerosol transmission might occur and impact people, both near and far from the source. So how does spreading of the virus occur in the air? And how far can the virus spread? So first of all, we have to talk about the different types of droplets. Large and small droplets. We've heard a lot about large droplets, which are generated when coughing or sneezing. However, there's a lot more to that. Large droplets are typically defined as being over 5 microns in diameter. Okay, one micron is 1,000 times smaller than 1 millimeter. All right, to give you an idea, if you look at 1 millimeter, that's fairly small already, and you divide it in 1,000 equal parts, it gives you 1 micron. So that's very, very small. You cannot see it by the naked eye. You would need an optical microscope to be able to see this kind of particles. And we know from scientific literature that coughing and sneezing typically creates large droplets, which are on the order of tens and hundreds of microns. Okay, so basically roughly 10 times smaller than 1 millimeter. These are fairly large and can almost be seen by naked eye, all right? But there are also much, much smaller particles that you cannot see. Why is it important? Because gravity and physics tells us that depending on the size of the droplets, they will not behave in the same way. Large droplets will fall to the ground much more quickly, and they will travel shorter distances, typically 2 to 3 meters, and they will fall to the ground within a few seconds, in about 5 seconds for 100 micron droplets. This has been actually calculated. I will give you the reference a bit later. So we know that, and now we understand a bit better why we've been told that we should keep distances 2 to 3 meters distance from people to people, okay, when coughing and sneezing. That makes sense. But this is only one part of the story, because the other part is that when you cough and sneeze, or even if you just talk, you also create very small particles, much smaller particles that you don't see, and which can travel much longer distances in the air, and which can stay airborne, okay, which can stay around floating in the air for very long times, actually for hours and hours. So it was calculated that a 1 micron particle aerosol, okay, so it's an aerosol which is made of small droplets and small particles which stay in the air up to 12 hours. Okay, 1 micron particles can stay in the air for up to 12 hours and reach much longer distances than 3 meters, because then they can travel, they just travel through the air, and they can travel for tens and probably even hundreds of meters away. Okay? Have you looked at dust particles floating in the air? When you look at dust particles, you can see them by the eye. 1 micron particles are even much smaller than that. It's just physics, you know. Dust particles, because they are small already, they can stay in the air, they can stay airborne for long periods of time. Now if you imagine much smaller particles, 10 times, 100 times smaller, they will stay airborne for much longer times. So the bottom line of this first lecture is really to tell you that coughing and sneezing is one thing, and you generate large droplets, but you also generate much smaller particles at the same time that you don't see. And in fact, just talking will generate these very small particles as well. And these will travel long distances and stay airborne for a long period of time. So if you're infectious, if you have a disease, if you're infected by the virus, and you generate these particles, you know, you're going to potentially infect people at very long distances. All right, so that's what you need to remember here. And remember also that, like what we've seen in the previous lectures, the virus is very small. It's 100 nanometers, which is even 10 times smaller than 1 micron, okay? These are tiny particles which are expected to stay airborne and float in the air for much longer times and reach very far, especially if you have convection, air movements. They can reach very long distances.